So if I look at my graph, I will go ahead and use those values. So let me go back to my table. So -2, -1, 0, 1, and 2. And again, those outputs, -9, 0, -1. 0, -9. Okay, so -2, -9 will be roughly here. -1, 0, 0, -1, 1, 0, 2, -9. Okay, so we can draw our curve, again, having an idea already how it takes shape. Let's graph. Just missed that point. That's good enough, I think. Okay. So yeah, determine the x values, or the values, excuse me, of x between which each real zero is located. Well, this point right here and this point right here are definitive zeros or x-intercepts. So my answers, if I were to just maybe jot them down off to the side here, are not between two values, but they are in fact two integer values, one at -1, the other at 1. Okay, so let's continue with looking at one more of these graph problems. And let's maybe take a look at number 6. With number 6, we've got ourselves f of x equals x to the 4th minus 3x to the 3rd plus 1. Let's go ahead and, yet again, make ourselves an xy table, and then graph on our calculators the function x to the 4th minus 3x to the 3rd plus 1. So hit y equals, we'll clear that. Minus 3x cubed plus 1. Oops, let me fix that. There we go. Alright, zoom 6. Okay, so this is a quartic. The end behavior is hopefully expected again. In other words, as we go to the left on the x-axis, the y values go up to positive infinity. As we go to the right on the x-axis, the y values go up to positive infinity. Okay, so I'm going to hit second graph to go to my table again. And these values look pretty high, so I might only actually graph -1 to 3. Because -2 has a very large y-coordinate, and 4 has a very large y-coordinate. Okay, actually I'm going, I don't have to go to 4, I don't even have to go to 3 necessarily, but certainly 4 and -2 are too big as far as the y values. So we'll go from -1 to 3. Still 5 values, so -1 and 5. I'll go ahead and put in 0, 1, 2, 3 now. And then the rest of those, 0, 1, 1, -1, 2, -7, and then 3, 1. Okay. So here we go, -1, 5, 1, 2, 3, 4, 5. I'm still off the graph, but still manageable, I believe. 0, 1, 1, -1, 2, -7, 3, -1, 4, -1, 5, 1, -1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 1, 2, -7, 3, -1, 4, 3, 1. Okay, and to make sure that I graph this correctly, I'm going to go back and just view this, hitting the graph button. So yes, it comes down, up, down, and then up again. Okay, so I'm going to be careful here with how I draw my function through my points. It looks like if we do this the right way here, it'll look something like this. Down, down, and back up. Kind of misdrew part of that, so let's fix that. There we go. And that looks pretty darn close to what I saw on the graphing calculator. Okay. Now as far as the x-intercepts or zeros are concerned, it appears that this particular value and this particular value are the spots where it crosses the x-axis. So 2 zeros are going to be found here, or at least 2 zeros that fall between 2 values that we'll go ahead and identify. We'll use the graphing calculator to give us a hand here. As you look at this, and you can even see here that this particular point is between 0 and 1. So let's go ahead and make a note of this. Between 0 and 1. Now it's important to note, once again, as we look at the y-coordinate of 0, it's 1. The y-coordinate of 1, it's negative 1. These two values are opposites. Well, they're actually positive and then negative. They are also opposites, but the fact that this is positive and the fact that this is negative speaks to the fact that this ordered pair, something comma 0, that x-coordinate has to be between 0 and 1. Do we know what it is? We don't. We could find it, but we're not asked to, so we will not. In a very similar way, we can find this particular ordered pair. At least we can find what two values it falls between. Again, we won't find it, but we know the y-coordinate is 0. Now if we look at the y values of 2, you get negative 7, and the y value of 3, 1. These two values, one's negative, the other's positive, so that particular point has to be between 2 and 3. And that's the gist when it comes to finding what values your zeros fall between. And of course, graphing your function with some very nice values. Not all your graphs are going to look quite this nice, depending upon obviously what values you choose. That will make your life hopefully easier as you go through it. Use your graphing calculator to its full potential. Let's move on to the next page. Analyzing graphs of polynomial functions. Maximum and minimum points. A quadratic function has either a maximum or a minimum point on its graph. For higher degree polynomial functions, you can find turning points, which represent relative maximum and relative minimum points. For example, so graph f of x equals x to the third plus 6x squared minus 3. Estimate the x-coordinates at which the relative maxima and minima occur. So maxima is actually the plural form of maximum. Minima is the plural form of minimum. So there could be more than one relative maxima, hence maxima, the plural. Same with minima. Okay, so make a table of values and graph the function. So because these table of values are already here for us, I'm going to kind of go back and forth between what I see here but also my graphing calculator just to justify some things. So y equals, let's type in our function x to the third plus 6x squared fix that. And then minus 3. Okay, zoom 6. And as anticipated, it is going to take the shape of a cubic. Now, they, as you can see here, they stretch their y-axis up to what appears to be, if they're going up by 4, 8, 12, 16, 20, 24, 28, 32. So I'm going to do that as well by hitting my window button. And my x min and max, and I might even stretch that to where they went only to negative 6, it appears here. So I think I'm okay with negative 10, but also positive 10. That seems to be okay. However, my y min and max, I think I'll make my y max, not my y min. My y min seems okay. Let's make our y max at what they do, or what they did, and that is 32. Okay. So that looks like a little bit of a better representation of what you see here. Furthermore, more importantly, let's hit second graph. So if we look at our table of values, they start at negative 5, and negative 5 should give us, there it is, 22. Negative 4, 29. Negative 3, 24. Negative 2, 13. Negative 1, 2. 0, negative 3. 1, 4. There it is, and then 2, 29. Okay. Some of these values we would be perfectly good with plotting. So let's maybe do some of these, if not all of them, to put it into perspective. And here are your values. When it comes to plotting points on graphs of functions, usually the more points that you plot, the better depiction you'll have. And it becomes even more imperative if in fact you don't have a graphing calculator at your disposal. So I'm going to go ahead and plot all my points, just all the points that they provided, and this very last point here at 2, 29. So as far as distinguishing between a relative maximum or a relative minimum, as we can maybe point out here and here, the maxima and the minima, well, there's only one maximum, which is here. Which has the ordered pair, as I'll highlight here, negative 4, comma, 29. And as they indicate, a relative maximum occurs at the value x equals negative 4, and a relative minimum here, they say occurs at x equals 0. There is only one relative minimum, and there's only one relative maximum. What is that ordered pair? Well, that is 0, comma, negative 3. Let's go ahead and identify x equals 0 as the x-coordinate of the relative minimum. They also do highlight that there is a 0 between negative 1, and there's another one between 0. Well, technically, 0 and negative 1 speaks to this 0. It's actually that particular 0. Which again, if you look at the sign change here, one's positive, one's negative. So it's actually between those two values. Pardon. And then this particular 0 right here appears to be between 0 and 1. So here's your other negative to positive interaction. So that speaks to not just the relative max and min values, but it also speaks to the zeros.